It's time to discuss voting. 4.2 Introduction to Voting. So, in this lecture, we're going to talk about some very basic foundations of voting. We're not going to go super deep into anything like the Electoral College in the US system, but rather we're going to just do some basic voting methods. And then you can see a little bit how we might apply these concepts to larger scale scenarios. So, introduction to voting. The first method that I'm going to talk about is called the plurality method. Now, this plurality method has a fancy name. You might be thinking, well, this sounds very difficult, but I claim you probably use this voting all the time. In the plurality method of voting, each voter votes for a candidate, and whoever gets the most votes, we say that they are the winner. We don't have to worry about majority. If you get the most votes, then you're a winner. So let's put that into practice. So before I read the scenario completely and ask a question, I need to explain this table. I have 50 people that ranked their preferences on chocolate bars, where 1 is their favorite, 5 is their least favorite. So the 5 chocolate bars, if I'm looking at this table, I had a caramel center, a vanilla center, almond, toffee, and just a straight up solid chocolate bar. What the heck does this table even mean for us? Well, let's look at this first column. The way that we read this table is column by column. So if I look at this first column, this column tells me, notice this number on the bottom, 17 people had this exact style of voting. 17 people exactly said vanilla is their top choice. Then almond was their second, followed by chocolate, toffee, and then caramel. So 17 people voted in this exact order. If I look at the second column, this tells me 11 people put toffee as their first choice and then solid chocolate as their second choice. I want to emphasize here, this does not mean out of the 50 people, only 11 people put toffee as their top choice. It just means 11 people put their voting in this exact manner. And I can see this in the third column. If I look at the third column here, we have 9 people who also put toffee as their first, but instead they put almond as their second choice. So this is something that we need to be very careful whenever we read it. This table actually does have a name. We call it a preference schedule. So let's go ahead and now read our question. According to this table, which chocolate bar should be considered the favorite of the people if we're using the plurality voting system? So again, plurality, we only care about the top choice. So let's go down and see. Looking at the caramel center, how many first place votes did caramel get? Well, let's see. In all of my scenarios for caramel, unfortunately for caramel, it looks like they didn't really get any first place votes. So it looks like we got 0. Let me actually change this to a pin. 0 first place votes. So just looking at, I'm guessing that caramel is not going to win this battle. Let's look at vanilla. How many first place votes did vanilla get? I'm going to look for all the ones for vanilla. Looks like here I have a 1. And how many people put vanilla as first? Well, that's exactly 17. So vanilla has 17 votes. Let's move on to the almond center. Almond, I'm going to look and see, do I have any first place votes? Here I do see a first place. How many people voted that way? I see 8. So almond has 8 votes. Next is toffee. How many first place votes do I see? If I'm going by the row, I see these two first places. For the second column here, I see 11 people voted this way and 9 people voted this way. So that means I have 11 plus 9 people voted toffee as their favorite. Or in other words, 20. And now we look at the straight up solid chocolate bar. How many first places do I see? I see a first here, I see a first here. How many does that account for? Well, here we have 3 people plus 2 people. So we have 3 plus 2 or 5 first place votes. So which one has the most first place votes? It looks like vanilla had the most. So if I'm using this plurality method, vanilla wins. Notice here in this plurality, there are some flaws. For example, look at vanilla. Vanilla did have the most first place votes, but it had a ton of last place votes as well. The issue with the plurality method is that it tends to ignore the extremes. It just looks at the bare minimum, is how I'll word it. So, how can we possibly overcome this? What are some other voting methods? So, let's go ahead into our second method of voting. The second method of voting that we're going to discuss is going to say, well, what if I do take into consideration those second places, third places, fourth, fifth, sixth, and everything? So this is what we're going to call the Borda counting method of voting. This method of voting says if I have n candidates, so n is just a number, then I tell each voter, I want you to rank your candidates from your favorite to least favorite. The favorite candidate will get the most amount of points from them, whereas the least favorite, they're still going to get some points, but not that many. So the way that we are going to do this is that we give those points based on their placement, and then whoever has the most amount of points is the winner. In other words, this gives weight into your second choice, or your third choice even. The key word here is the person with the most points is the winner, not the person with the most first place votes. So this is a little bit abstract. So let's say I worked with this. Suppose I had 3 ice cream flavors, the basic ones, chocolate, vanilla, and strawberry. And let's say that I ranked them myself and I said strawberry is my least favorite. I'm going to give it a 3. Vanilla is my second, middle of the road, and chocolate is my favorite. I want to give it first place. That's my first pick. So I have 3 options, so I'm working with at most 3 points each time. Strawberry was my least favorite, so I said, let's give it 1 point. Vanilla was middle of the road, so I gave it 2 points. And chocolate, I gave it 3 points because it was my top favorite. I want to emphasize here, it went 1 point, 2 point, 3 points because I had 3 options. If I had 4 options, we would do 1, 2, 3, 4 points. So let's go ahead and put this into practice. And this is going to be quite some space. So if you're writing this on a sheet of paper, I'm recommending starting a new page or making sure you have at least maybe half a page of writing. So let's say I'm working with the members of a club and they want to go ahead and elect a new club president. They've got 4 nominees and they decided I want to use the Borda counting method. One thing I forgot to mention, by the way, you might hear this more commonly called ranked voting because you can rank your candidates and then your second, third, fourth choice get some points as well. Back to the question. Let's say I have 100 members of the club, and then they mark their ballot as shown in the table below. So again, this is our preference schedule. And to read it, we said that 30 people voted in this exact order. 24 people voted in this exact order. So on and so on. We need to calculate how many points each candidate is going to win or gain, to be exact. Let's start off with Avalon. It looks like here we had some second place votes and then some third place votes. So he looks very middle of the road. He's not anyone's top candidate if I'm reading down all of these, but he's not disliked. He's acceptable, is the word we'll use. So, how many points does second place get? Remember, how many candidates do we have here? We have 4. So, that means if they were voted first choice, they get 4 points. If they were voted second place, they got 3 points. If they were voted third option, they got 2 points. If they were voted last or fourth, they got 1 point. So let's read it for Avalon. And just to ensure that we're all focusing on the same thing, I'm going to highlight this. See if I can make this a little bit larger. We're focusing on Avalon. So remember, we have a second place. How many points is second place? They get 3 points. Next, second place, we get 3 points. Second, we get 3 points. Second, we get 3 points. A little repetitive. Third, something different. We get 2 points. And second, we get 3 points. And remember, these points are for each individual vote. So we're not just done with 3 points, 3 points, 2 points. We need to see how many people voted that way. This is where now we're going to look at the number of votes. So I'm going to go ahead and write this. So looking at my first column, 30 people gave him second place. So I'm going to do 30 times 3. What about the second column? We have 24 people also put him at second. Then 18 people. Then 12. I'm going to try to fit this in. It's a little messy. I'll apologize for that. Plus 10 voters. Plus 6 voters. Let me rewrite that 6. That's a little bit of an ugly 6. And let's see what we get. So 30 times 3, we get 90. 24 times 3, what do we get? 60 plus 12, 72. 18 times 3, we get 30 plus 24, so 54. Perfect. 12 times 3, we get 36. Plus 10 times 2, we get 20. 6 times 3, we get 18. So adding all these up, 90, 72, 54, 36, 20, 18. We get 290 points total. So Avalon has 290 points. I'm going to go ahead and write that here. 290 points total. So now we got to compare to Branson, Columbus, and Dunkirk. If you want, you can go ahead and try to attempt this yourself and skip forward, or you can stay for the explanation as I talk through this. So now let's work with Branson. So let me clear all this up as fast as I can. We're focusing on this second column now. Second row. So just for work, I'm going to go ahead and mark down the points. First place gets 4 points. Fourth place gets 1 point. Fourth place gets 1 point. Third place gets 2 points. Second gets 3. And first place gets 4. So a little promising. It looks like this candidate, Branson, is a little bit on the extreme. People either really like this candidate or they really don't, because they have 1 or 4s. But again, we have to make sure we account for the number of voters. So 30 people voted Branson first. So that's 30 times 4 points. We have 24 votes here, plus 18 votes here. 12 votes for these third places. 10 votes for this second place. and 6 votes. So I'm taking the number of votes times the number of points. So once again, we're going to multiply and then add them up. 30 times 4, we get 120, plus 24, plus 18, plus 24, plus 30, plus 24. So what do we get whenever we add these up? 120 plus 24, plus 18, plus 24, plus 30, plus 24. We get 240. So Branson gets 240 points. I want you to notice something. Even though Avalon had no first place votes, they still have a higher overall score, larger than Branson. So right off the bat, I already know Branson is not going to win because they're not first in terms of points. So Avalon is still taking the lead in terms of points. Now let's check our third candidate, Columbus. So for Columbus, once again, for convenience, I'm going to go ahead and mark the number of points that we get. And let's use what color do I have access to? Let's use this sort of purple color. So for Columbus, we have a third place, which translates to 2 points. I'm going to go ahead and put parentheses around it because we know we're going to multiply. Third place is 2 points. First place, that's nice, 4 points. Fourth place, rough, 1 point. First place, 4 points. Fourth place, 1 point. And then we account for the number of votes and multiply them. 30 votes for third, 24 votes for third, 18 votes for third, 12 votes for fourth, 10 votes for first, and 6 votes for fourth. So another candidate that's a little bit on the extremes. Cleaning these up, we're going to get 60 plus 48 plus 18 times 4. We get, what's that? 72 plus 12 plus 40 plus 6. Adding up to a nice total of 60 plus 48, then 72 plus 12 plus 40 plus 6. We get 238. So Columbus has 238 points. So it looks like Avalon is still in the league by a landslide so far, 290. In the lead by 50 points. Now let's check out our last candidate, Dunkirk. Let's see how they're doing in the polls. So once again, let's mark my votes based on their point value. Let's use a nice. So Dunkirk, fourth place translate to 1 point. First translate to 4. Third translates to 2 points. First is 4 points. Fourth is 1 point. Third is 2 points. And now we account for the voters. 30 voters put him last. 24 voters put this Dunkirk first. Plus 18 times 2, 12 voters in this manner. 10 and 6. So we get 30 plus 24 times 4. We get 80 plus 16, giving me 96. Plus 18 times 2, we get 36. 12 times 4, we get 48. 10 and 12. So let's see what happens whenever I add these values together. We get a nice total value of 232. So Dunkirk gets 232 points. So based off these 4-point values, who's going to be the club president? Well, Avalon has the most amount of votes, so they should be the club president. In other words, Avalon wins in the polls. In fact, by a large landslide of 50 points. Or you can say 58 points from the lowest candidate. So again, it's quite interesting. Avalon was not anyone's favorite, but they also weren't anyone's least favorite. They weren't loved, but they weren't hated. So they were a little bit of a compromise or a neutral candidate, it looks like. And because of that, they actually won this election. So this is our ranked voting. You don't necessarily need the top vote to win. You just need the most points to win. All right, so we talked about the Borda counting method. We have plurality, we have Borda counting method. We're going to talk about one more method. So the last method we're going to talk about is plurality with elimination. This is going to be a compromise between the two. It's a mix between plurality and a mix between the Borda counting method. So this is going to also consider your second choice, third choice, and so on. So let's talk about it. Let's say I work with this scenario. I have 30 members of a regional planning board, and they want to decide, we want a new airport, we don't know where to put it. They hired some consultants, and then the consultants recommended 4 different sites: Apple Valley, Bremerton, Coachella, and Del Mar. So the 30 members of the board voted on where they think the new airport should be, in which of the 4 cities, according to this preference schedule. In our plurality with elimination method, what we're going to do is we're going to count who has the most first place votes and then who has the least, more so. I should have said we really care about the least votes. Because what happens with the least votes? The option with the least amount of votes for first place gets eliminated. And then we recount and reorganize our votes. So we continue this method until we only have 2 candidates, and then we see which one has the most first place from there. Now, there is a little bit of a flaw in this method. Sometimes you might end up eliminating all your methods if we have a tie. So let's see how will this work. So I should look at this table first off. Let's look at our preference table. How many first place votes does each city have? Let's see, Apple Valley, if I go down the row, first place votes, it looks like it has 11 total. Bremerton has one column with first place, or 2 votes. Coachella has a first place with 12 voters. Del Mar also has a first place with 5 votes. So which one of these 4 options has the least first place votes? Well, from these 4, Bremerton has the least. It's only got 2 first place votes. What we're going to do is we're going to say, let's eliminate Bremerton. It's not on our mind anymore. But what implications does it have? Well, the implications are now everything in our schedule must be moved up as needed. For example, if I look at this last column, originally it was first, but now that Bremerton is off the table, Coachella now moves to be a first, Apple Valley moves to be a second, and Del Mar moves to be third. And we do the same thing for each column. So we're moving up as needed. I'll do it also with the first column, excuse me. Here, Bremerton was originally second, but since it's gone, first place doesn't get affected. That's fine. But then third moves up to second, and fourth moves up to third. So I do this for all of my columns. If I do this for all of my columns, then I'm going to get something that looks a little bit like what I have here. Again, we eliminated Bremerton, and then we readjusted the schedule. That is our round 1 of elimination. And now we're going to repeat. This is our new table. that we're not worried about this anymore. Once again, we're going to count who has the most first place votes. So Apple Valley, I see a first place column, which correlates to, let's see if I can get this to work. I might be a little bit frozen. You'll have to give me a moment. Go. So Apple Valley, we see a first place, which we have right here. And how many votes does it have? It looks like it has 11. And it looks like my tablet might be having some issues connecting. It has 11 votes. Looks like I'll have to do this by hand. Use the ugly handwriting. What about Coachella? Coachella has a first here and a first here. So the first column has 12 votes, and then the last column has 2. So we have 12 plus 2, or 14. Let's see if I can draw with my mouse. And then Del Mar, how many first place votes do we have? Well, we have 5. So Del Mar sticks with 5 votes. A weird looking 5. So which one of these has the least number of votes? Well, I think we can pretty clearly see Del Mar has the least number. So that means Del Mar is now off the table. I eliminate Del Mar and then readjust my table as needed. So now I'm left with Apple Valley and Coachella. Now that I'm down to 2 options, I can go into my third round and my final round actually. How many first place votes does each city have? Apple Valley now has a total of 11 plus 5 votes, so 16. That's coming from these 2 columns. And then Coachella appears to have 12 plus 2, or 14 votes. So which one has the least amount of votes? Coachella. So I eliminate Coachella, leaving me with my final choice of Apple Valley as my new spot for the airport. So this is our plurality with elimination. All right, so I've talked for quite a bit. You can go ahead and look at this last example if you'd like and see if you can complete this. Let's say if I want to work with a university club and they want to decide which sport should be added to the university's programs between lacrosse, squash, rowing, and golf. See if you can figure out which sport should be accepted if we are using the plurality with elimination method. Take some time to complete this. If you have any questions, you can always reach out to me and we can talk about it. Besides that, I'll see you for actually the next module.